Okay, so I is the square root of -1. That is how we get imaginary numbers. Another important fact that's going to matter today is the fact that if you square I, then you get -1. That's because I squared will be I times I, which will be the square root of -1 times the square root of -1. And when we multiply those together, we get -1. So that's why I squared is equal to -1. Okay? A complex number is another phrase for an imaginary number, but usually complex numbers have a real part and an imaginary part. So this is traditionally what a complex number looks like. Something plus bi, right? A is the real part, and bi is the complex or the imaginary part, right? Because a does not have an I with it. So it's the real part, bi is the complex or imaginary part, okay? So first we're going to create imaginary numbers. All three of these are imaginary numbers. Why are all three of these imaginary numbers? Because there's a negative where? Inside the radical or inside the square root, right? This one has a negative on the outside. Does that become imaginary? No, right? The negative on the outside is not going to have anything to do with imaginary numbers, right? It's the negative underneath that does that. So the first thing I recommend doing is breaking it up into the square root of 36 times the square root of -1. So it's taking that -1 out, just like we used to break up radicals. We're allowed to do that because 36 times -1 is -36. Okay, that way you're kind of keeping this separate because this will be your I. And what is the square root of 36? 6. And what is the square root of -1? What did we just say that becomes? I. So this is just 6I. So the square root of 36 becomes 6I. So if you break it up into the number and the negative, then you can just simplify your radical. So let's do that with b as well. So we'll break this up into the square root of 72 times the square root of -1. But is the square root of 72 a perfect square like 36 was? No, 72 is not a perfect square like 36 was. So we're going to have to simplify this radical, right? This is the hardest part about today, is going back and bringing back our simplifying radicals. So we're going to find the biggest perfect square that divides 72. Remember, that's how we do that. So remember, our perfect squares are 4, 9, 16, 25, 36, 49, ... So if you don't already have a calculator and you need one, go grab one. And I want you to find the biggest perfect square that divides 72. So write it down.
36.
Good question. Use your calculator if you need to. Find the biggest perfect square that divides 72. If you need to grab a calculator, now's a great time to do that. So 4 and 9 are both perfect squares that divide 72, but there's a bigger one. What's the biggest one? Anyone find the biggest one? 36. Yeah, so if you did 4 or 9, you're not wrong. Those are perfect squares that divide it, but we want the biggest one. So the biggest one is 36. So remember, we take the 72 and we break it up into 36. And what was it times 36 that gave you 72? 2. We still have that square root of -1. So 36 times 2 was 72. So we break up 72 into square root of 36 times square root of 2. And now, what does the square root of 36 become? 6. Can I do anything to the square root of 2? No, it stays under the radical. And what does the square root of -1 become? I. It doesn't really matter where you put that I because it's all multiplication as long as it's outside the radical. But usually we will write the answer as 6I radical 2. We put the I with the number on the outside. But these are the same thing because it's all multiplication. That's just usually how you'll see the answer written. Any questions about B? All right, let's do C together. So first, this negative on the outside just stays there. Let's separate the 52 and the square root of -1. And then I want you to try to simplify the rest of that on your own. So find the biggest perfect square that divides 52, because it's not a perfect square itself, and try to simplify the rest of that on your own. I think that's 54. What perfect square divides 52? Anyone find one? 4. Yep, 4. That's the biggest one. It doesn't go any bigger than that. 4 times what was 52? 4 times 13. And 26 times 2 is also 52, but 26 is not a perfect square, right? So remember, we need a perfect square. So break this up into the square root of 4 times the square root of 13. We still have our square root of -1. We can do the square root of 4. What does the square root of 4 become? 2. We still have the negative out in front. You can't do anything to the square root of 13. That does not simplify. And then what does the square root of -1 become? I. If you want to put it at the end, that's fine. But usually we put it in the front with that number. If you put it out here, that's fine, as long as it's not under the radical. Any questions on that one? All right, for D, let's separate the number and the -1. Is 7 a perfect square? No. Is 7 divisible by any perfect square? No. Is it divisible by any number besides 7 and 1? No, right? So we can't simplify the 7. That'll stay under the radical, but what does the square root of -1 become? I. So as long as it's outside the radical, it doesn't really matter whether you write it like that or like this. Either one of those would be fine. Okay, so this is the hardest part, is bringing back the simplifying radicals about today. Everything else is even easier. Any questions about this refresh of simplifying radicals? Okay, so now let's add and subtract some imaginary or complex numbers, okay? So these here, we have 2 complex numbers. This is a complex number and this is a complex number, and we're adding them, right? Because this part here is the real part, it doesn't have an I, and this is the imaginary part, it has an I, right? Then this is a complex number, this is the real part, this is the imaginary part. Here we're subtracting 2 imaginary complex numbers. Real part, imaginary part, real part, imaginary part, okay? When you're multiplying, adding, and subtracting, just think of I as a variable like x. Everything works the exact same way, right, as if it was x, okay? So here, can I add 8 and 6i together? Are those like terms? No. But what terms can I add together? 8 and 3, right? Because those are the real part. They're like terms. So you're going to add the real part and then add the imaginary part, just like you would if it was an x, okay? So you're going to add 8 and 3 together. So that'll give you 11. And then you're going to add 6i and 2i together. So that'll give you 8i, and that's a positive 8i, because those are like terms. If you had 6x and 2x, you would say that was 8x, right? So now you're just saying it's 8i, and then you're done. Yeah. Yep. So I want you to try B on your own. Now you're subtracting. So you're going to do the same thing, just subtract. Be careful with the subtraction. Yeah. All right, compare what you got with your table for B. All right, so I think everybody for the most part got -2 because you did 4 minus 6 to get -2. Then the tricky part you got to be a little careful about is the i's because we're doing 5i minus -3i. And when I do 5 minus a -3, that's going to become a 5 plus 3, right? So this becomes 5i plus 3i. So this should be 8i. If you had a 2 there because you were thinking 5 and -3, you either put your negative at the end or you forgot that you were subtracting. Okay? Any questions on B? Pretty simple, right? Nothing really that new. Any questions? All right, now let's multiply. Last thing we're going to do today. We're going to multiply some imaginary numbers. Again, you're going to treat I just like X. Okay? We've already multiplied things like this together before when there was an X in there. What do we do when we're multiplying things like this together? What do we do? That was an X right there. You just distribute, right? Or FOIL, or use your box method, right? So you're going to do 8 times 3, 8 times 2i, right? And remember, the I, just treat it like it was an X. So you can either distribute, use the box method, or you can FOIL. All of those are the same thing. So if we distribute, we're going to do 8 times 3 and 8 times 2i. So 8 times 3 will be 24. When that comes back. 8 times 2i will be 16i, just like if it was 8 times 2x. 6i times 3 will be 18i. And then this is the only tricky part you got to be careful with here. 6i times 2i. What is 6i times 2i going to be? 12i squared, right? If that was 6x times 2x, it would be 12x squared. So 12i squared. And then this is the only thing that changes with this type of problem with imaginary numbers is when you have an I squared. That's the only thing you need to be on the lookout for. If you have an x squared, it just stays x squared. But what do we know I squared is equal to? -1. Anytime you have an I squared, you can't leave it in your answer. You got to turn it into -1. So this right here is going to be 12 times -1. So it's going to turn it into a -12. So anytime you see I squared, it's going to turn into -1. So that turns into, it was a +12, but it's 12 times -1. So now that becomes a -12. So is there anything else I can do now? Yeah, now I've got some like terms. And I have 2 like terms here, right? The 12 and the -24. I'm sorry, the 24 and the -12. So that will become 12. And then I've got 2 like terms in the middle, 16i and 18i. And that will become plus 34i. So the only thing that you're not used to at this point is that the I squared has to become -1, which maybe you remember that, but if not, it's a good refresher. And it just gives us some more like terms to combine once that becomes a -1. All right, try B on your own if you haven't already. So when you distribute, you should do 4 times 6 will give you 24. 4 times -3i will give you -12i. 5i times 6 will give you plus 30i. 5i times -3i will give you -15i squared. So this is the one part you need to be careful of. Make sure you have -15 from +5 times -3, and then your I squared. The I squared will become -1, so this will be -15 times -1, and so that will become a +15. Then you can combine like terms. (24 plus 15 is 39. And -12i plus 30i is 18i. And that should be your final answer. Any questions on B? All right, on the back page, there are a few problems at the top where it says you try, and I want you to try these on your own now. This is it. That's all we're doing. We're simplifying radicals that turn into imaginary numbers. We're adding and subtracting, and we're multiplying. But just a kind of a couple heads up, there are a couple that look a little different. Number 4 looks a little different than one of the problems that we did. But what are we doing with number 4? What are we doing here? 5i what? Are we adding 5i to these guys? No, we're just multiplying, right? So will we still distribute here? Yeah, we'll still distribute. And then the other one to be careful of is number 9, okay? A lot of people try to square the 2 and square the -3i, but I can't do that. What does it mean to square something? Multiply by itself, right? So this is 2 minus 3i times 2 minus 3i. Right? Squaring something just means multiply by itself. So I want you to work on each of these on your own. If you're stuck and have any questions, let me know. So these are the answers to 4, 5, and 6. Make sure with number 6 you don't multiply and distribute. You're subtracting. right? So make sure you subtract instead of distributing. So there were a couple of common mistakes with number 4. So just a reminder, when you do 4, you're distributing. So you're going to do 5i times 3i, which is 15i. And then 5i times negative 7i, which will be negative 35i squared. Right? Because you're going to have 5i times 7i. Then this becomes 15i plus 35 because the I squared becomes negative 1, and so that will become a plus 35. And then I'm going to put the answers up for 7, 8, 9, and 10, and you can ask me questions if you did not get those answers.